Hi, my name is René Mania, and I'm a PhD student at the Geosciences in Potsdam, Germany. Today, I would like to talk about the different scales of surface deformation at Bezymianny volcano in Kamchatka. This volcano produces an average 1 to 2 explosive eruptions per year, and today I would like to put the focus on the 20th of December eruption in 2017. This produced an ash column reaching altitudes of more than 10,000 meters and thereby strongly affecting the local air traffic. A common precursory sign is the seismicity. And here in this graph, we can see on the y-axis the accumulation of volcano-tectonic events. And we can see a clear exponential increase during the last days preceding the eruption. At the same time, we observed the formation of a major fracture at the summit, as seen here in these TerraSAR X spotlight amplitude images. A recent study investigating the seismicity at volcano has shown that the very shallow reservoir is located at about 1,000 meters above sea level, and that the eruption is mainly driven by gas-enriched magma. However, there are still questions standing out. So for one is, are there any other precursory signals characterizing the eruption? And how is the uppermost magmatic system characterized? For this reason, I want to show you the two last ascending and descending interferograms. And what we can see here is that the initial deformation preceding the eruption started during the beginning of December. At the same time, we can see in this spectrogram a high density of very low frequency events. And this burst of aseismicity is likely driving the deformation detected with InSAR. This is also called tremoric activity, is often associated with the ascent of gas-enriched fluids into the very shallow magmatic system. In the next step, I unwrapped the data and corrected the atmospheric delay by using GACOS. And you can see the result here on the left of this figure. Then I applied the inversion modeling software GEBIS by using the point compound dislocation model. The resulting optimum is visualized in the middle, and we can see that it fairly matches the observed deformation fairly well. However, there's still some residual left, and we can see that also very clear in the profile. Nevertheless, it's still very close, indicating that the source depth at least is rather reliable. In general, we can say that it was an inflation-like deformation source with a volumetric change of about 140,000 cubic meters. Now, when we look at the depth of these sources, of the source, for the descending as well as for the ascending track, we can see that the location is fairly similar, but located above the previously inferred volcanic source, and indicating that it's actually located in the carapace of the source. Moreover, when we look at the geometry of the ascending solution, it looks like a dike-like intrusion that may reflect a conduit. Overall, we can say, I can say that the InSAR deformation occurred earlier than the precursor seismicity, and that reservoir pressurization as well as the initial conduit formation is likely driven by gas-enriched magmatic fluids at very shallow depths. Thank you for your attention. If you are interested in studying volcanoes such as Bezymianny and Kamchatka, the region has been recently assigned as a supersite. So if you are interested, you can send me an email and we can talk about further details. Thanks a lot for your attention, and bye.